Okay, we're now in lesson 2.2, which is limits computational techniques. I'm going to go through this pretty quickly, but in class intend to spend some more time on some specific things. Okay, so Theorem 2.2.1, these limits right here. You need to know these limits. You need to be very familiar with these limits. We're going to look at some graphs to see if we can make sense of these limits. So let's look at the first one. The limit as x goes to a of a constant is equal to a constant. So if a function is a straight horizontal line, if it doesn't change, then the limit of a constant is equal to a constant, regardless of whether x is approaching a specific point called a, or if it's going to positive or negative infinity. I'm going to go ahead and zoom in on these. Hopefully you can see them a little bit better. So the limit of a constant is a constant. The limit as x goes to a point of x will be that point. So think of this right here as y equals x. If you go to positive infinity, then the limit of x will go to positive infinity. And if you go to negative infinity, then the limit of x goes to negative infinity. If you go to 0 from the right of 1 over x, then the limit will be positive infinity. If you go to 0 from the left of 1 over x, then the limit will be negative infinity. And if you go to positive or negative infinity for the reciprocal function, 1 over x, then the limits will be 0. So, in 2.2, one of the first things that you need to be familiar with is Theorem 2.2.1. You need to know, you need to understand these limits.